All right, welcome back to the second lesson. In this one, we can participate and ask as many questions as we like. I'm starting with transformations first, because then after transformations, we will go into vectors. And then from vectors, we will go into matrices. And I believe this is how the logical order of things will work. After that, we will in between always refer back to geometry. And as we continue with later on geometry, we will go into bearings and finish some of the trigonometry ratios that we have started on as well. And finally, probability and statistics. Probably we will do that if we are allowed to go back to school. And I believe you will be ready for the exams to come. So we have about 21 slides that I want us to look at over here, and I will be explaining them. Come again?
Is this part of geometry?
Everything is linked, my dear. You will see now where geometry comes into place. So geometry just basically refers to drawings, okay? So every time or anything you see that has drawings is geometry, okay? So if we are drawing a graph, that is geometry. If we are drawing a triangle, that's geometry. If we are drawing in shapes, transformations, that is geometry, okay? So everything is linked to geometry. It's just within geometry, it's so big, it has subtopics that we must go through, okay? I hope that answers your question. All right, let's proceed. So over here, we have transformations that we will be looking at. And under the transformations, we will be focusing on the following ones. We will be focusing on translation. That will be number one. I don't know which other ones, how the order goes, but we have rotation, we have reflection, we have enlargement, and invariant points. It's higher level, but we will talk about them a little bit because invariant point has something to do with our line of symmetry, okay? So when we look at the line of symmetry later on, invariant points might come into play as well. But for future aspects, it's important to talk about it. So line of symmetry also comes in here as well. And we have to focus on that again. So that will be probably the last one that we focus on as well. So let us proceed in the following two things, all right? Before we get started, maybe I went a little bit too far, but let's just quickly explain. All right, before we get started with this, I just want to mention that our representation here is just giving us a little introduction to how sometimes the translation is represented, okay? And it shows us it's in a vector form, all right?
Also here.
Come again?
Here also.
Okay, sorry, I'm muting Mecca there. So,
I didn't mute myself in the group.
okay, I muted you again, Mecca. If you have a question, you can unmute, right? So 3 means units to the right and 1 unit down. That's basically just what it means. So this number says go 3 to the right, and this number means 1 down. Okay, now I am going to show you again, there's a graph over here. So with the graph, when we say to the right, or if it's positive, we go to the right. If it's negative, means go to the left, okay? So this is basically what this one means over here. It means 2 units to the left and 5 units up, okay? So instead of saying units, we say blocks, okay? We can replace units with blocks. And normally these blocks are on our graph paper that we will be using. Now, I just want to, yeah?
Can you please say again?
Yeah, I will say again, okay? So please note, okay, I will remove that thing. We are busy with transformation. And as I told you that transformation and vectors, everything is linked. Okay, everything is linked. So as everything is linked, right? You have to know certain things, because I was about to draw something very important. So if you are getting a representation of a transformation or this translation things that we need to do, any transformation that is in this form, this means it's in a vector form, okay? So what this means is the number on top, this number 3, means 3 to the right. So just if you are starting at this point over here, just it means go 3 to the right. So it will be 1, 2, 3. That will be 3 to the right. Okay. The number at the bottom, if it's a negative number, it means go 1 block down. Okay. So I'm here. So it means I have to go 1 block down over there. This is what it means in vector form. Okay. So in vector form, that is what it means. You go 3 to the right because there's a positive number over there. If it's a negative number at the bottom, it means 1 down. This one means you go 2 to the left, okay? Because it's a negative number on top, we go to the left, and it's a positive number at the bottom, it means we move up, okay? So in another way to represent this, or an easier way, is the following. The number on top, that is always going to be our X value. The number at the bottom is going to be our Y value, all right? That is how you will look at it. The 3 is your X values. The Y is the minus 1 that we have here. Same with this one, the minus 2 is your X values. The 5 is your Y values. So that is what we have to basically focus on. All right. So again, the X and the Y's come in, the graph paper comes in, drawing these points and finding out where we need to draw them also comes in. All right. So in another sense, here we have 2 triangles. Okay. And with the 2 triangles that we have here, let me just clear the screen quickly. It says, what is the vector translating A to B? And then that is now this one, A to B. And then the other one is asking what is the vector translating B to A. So let me just quickly explain what we mean by A to B. So you start at A, all right, and you want to go to B, all right. So what did we use there? How many things did we change? So in order for us to find out how did we move there in vector form, we first select any given point on the triangle, preferably the vertices or the corners, right? So for now, let's select this point over here. That is now my A, and I want to go to B, right? At the same point at B, I want to go to this point over here. So instead of just drawing a line that we don't draw a line. So all we need to do is count how many places to the left, how many places to the right did we go. So in our case, we are not moving left, we are going right. So if we are going right, that means our top number must be positive. So how many blocks or units did we go to the right? We went 1 block, 2 block, 3 blocks. So I went 3 blocks right, okay? Why did I stop? Because you can see now they are on the same line here, okay? Those 2 points are now on the same line. This is now for translation. Then I ask myself now, okay, I'm not at the place yet, so I still need to do something. Am I going up or am I going down? Or I'm going down now. So if you're going down, then this will be 1 block, 2 block, 3 block, 4 blocks down. So if I'm going down, 4 down, stuff to write. Okay, I went 4 down, and if you are going down, this becomes a negative number, right? If you are going up, it will become a positive number, all right? If you are going right, positive, left, negative. So where is that up and down and right, positive and negatives coming from? from our normal coordinates. The x values to the right, they are all positives, right? Remember these quadrants that we talked about? This one will be negative, positive, right? This one is negative, negative, and this one is positive, negative, okay? So if you are going down, your y values are all negative, okay? If you are going to the right, your x values are all positive. If you are going to the left, your x values are all negative, and if you are going up, your y values are all positive. So you have to know your Cartesian plane also. If you are moving up, positive. If you are moving down, negative, okay? And that is how we represent it now. So since I know this is my x goes on top, so the 3 is positive. The 3 is positive, and I'm going down, so that is my y value that is changing, and the 4 will be negative, and that is how we represent it. And in the same vein, if we are now moving from B to A, then we do the same things. Instead of moving left from B, we have to now move to the right. 1, 2, 3. Okay, so I'm moving 3 to the left. Sorry, I'm moving 3 left, and then I'm going 1, 2, 3, 4 up. So that will be 4 up. And then I use this to help me identify. If I'm going left, it must be a minus. That's where the minus comes over there. If I'm going up, it must be a positive. That's where the positive comes over there for my x and y values. All right. Is that okay so far? Victoria?
So it's just the inverse of the other one.
Yes, you can call it like it's an inverse. But I don't want to just call it an inverse, because you also have to know how did we get to that inverse, because here is it either by scale. If you are looking at vectors, then you have to say, is it by scalar multiplication or is it by vector multiplication? So I don't want to go into that scalar multiplication and vector multiplication now. It will be confusing a little bit. So as we proceed, let's just understand that here we are just looking at the blocks, okay? And we are representing the blocks like this. And also this is also a vector form. All right. The reason it's a vector form is because we are going a certain distance in a certain direction. Okay. This is what I said in the previous one when I did the explanation. We have the reason we are calling it vector is we have a number that is our size. Okay. And we have a direction. Okay, I'm trying to write very small. So when you have two things, that becomes a vector. When you only have one, we call it a scalar. Okay, so if there's only one thing, then it's a scalar. All right, so for vectors, there's always size, a number, and then there's a direction. Is it left or is it right? In our case, our left and right are represented by positives and negative numbers, right? Or up and down, that is also a direction. So that's why they call it vector form, okay? Let us proceed. All right. So the diagrams here are just explaining what I drew in, okay? They selected a different point, all right? So the point they selected was this one, and it still produces exactly the same answers as we want, all right? After translation, a shape will be the same size and the same way round orientation in a different position. So translation, this is basically the definition. A and B are identical, okay? Only difference between A and B is where they are located, okay? The position. A and B orientation means this point of A is facing up, this point of B is also facing up. They are in the same points and order that they have. All right, then we look at the following one here. It says now we have to translate shape C with the vector 2, 3, okay? So again, we can write this as follows, right? Change the shape C, okay? X values by 2, all right? Y values by 3. make that by 2 and by 3 correctly. All right. So change the x values by 2 and change the y values by 3. So again, you will start at the given point. Then we will go to x values positive is to the right. So we'll go 1, 2. And then y values is positive. We will go up 1, 2. That will be the first point over there. All right. We do that for the all the other points. We do the same thing. So for this point over here, you just follow the same rules. 1, 2. Okay. And then 3 up. 1, 2, 3. So that will be the point that we have there. For this point, same rule. 1, 2, 3 up. 1, 2, 3. That will be the point that we have there. And then finally, when you have all your points, then you just join the points together. Okay. So all the points, we join them together. Please mind my ugly handwriting. And then that will be the translated shape by this given vector. Okay, that's just an example that we're showing you here, right? So it will basically show the same things what we did, and that is just basically explaining everything what we did, all right? And the shape is exactly where we left it. All right, so over here again, we have some examples again, which is the same. I'm just going to move it in just to show you how it is as well. So we have translate P by this vector -4 and 2. So we will start at a given point, and then you go -4 means 4 to the left-hand side. So it's 1, 2, 3, 4, 2 up, 1, 2, that's a point. You do that for all the points everywhere, okay? Then we get the shape. This one again for Q, it says 3 and -5, that means 3 to the right and 5 down, that's a point. You do that for all the given points, all right? So once you do that for all the given points, you will end up with a new shape, okay? And normally we call this first shape the original shape, and then we call the other shapes the primes, like Q prime, P prime, and so forth. Those symbol is supposed to be P prime over there, okay? And that's what we do for all of them all around. This is just translation. The shape size is not changing. The shape positions are not changing. Only, the position is changing of the shape, but the size and the direction, how the shape is showing is not changing at all, right? So it says here, can you see how the coordinates of the vertices corners change? Okay, look at the coordinates of one vertex at a time, and then the coordinates is basically what we are changing here. So let me just write in one example for the coordinates. For example, for Q over here, the coordinate at that point will be for X is 1, and then Y is -2. I think I should use another color so that it's a little bit visible. Okay, we have 1 here, 1 here, and 2. And then the other one over here, the same point over here, the coordinates for X is now 4. And the other one for Y is -7. All right. So if you look at this answer here, and you had to change the given points using coordinate systems, right? If you know the coordinate of this, and it says change the coordinate of X by 3, then all you do is say 1 plus 3 will give me a 4. Is that not so? Because this is my X, this is my Y, all right? So I will write it in here, okay? So if the coordinate that we have is 1 and 2, I don't know if that color is okay. Let me find a better darker blue color. All right, let's look at the coordinate here again, all right? That coordinate is X is 1 and Y is -2, all right? If I write it in this column form or vector form, we have to translate. So you just add, all right? What do we add? We add this coordinate. X is always on top, so my X is 1. My Y is at the bottom, it will be -2, all right? So I just changed this coordinate, which is in a row, into a column, like a vector now. And this will give us a new coordinate. The new coordinate will be You just add the tops, add the x together to give you a new x, add the y's together to give you a new y. So 3 plus 1 is 4. Minus 5 plus minus 2 is minus 7. That is your coordinate for the first point. All right, we can do that for all the points. Let's look at this point over here. Over there, we have x is 2 and y is 0. Okay, so if I do it, let me do it way on top here so I don't get everything confused. So we will have 3 and minus 5. That is what we need to change it by. We add it with the coordinate that we found. X is 2, y is 0. And that will give us a new coordinate. We just add the tops. 3 plus 2 will give us a 5. Minus 5 plus 0 will give us a minus 5. And that is the new coordinate. Let us verify these two coordinates. The first one means that when x is 4 and y is minus 7, that is that point over there. X is 4, y is minus 7. We got a point, and you can see it's at the right place where we want it. The other one, when x is 5 and y is minus 5, so here is x is 5 and y is minus 5. Minus 5 is over on this line here, and there is the point where the 2 points meet, and you can see x is 5, y is minus 5. So we can also use coordinate systems here just by applying this simple rule. And you will notice now what we are actually doing here is a form of vector operations. We are adding one vector to another vector to give us a vector. But we can also call this coordinate operations, right? If you don't want to do it in this column way, it's easier to add. Another way would have been to say, okay, you have the coordinates 3 and minus 5, and then you put the other coordinates here, minus 2 and 1, 1 and 1, minus 2, and then you add them. But it doesn't look nice if we add them up like this. It's very confusing. So if you add them in a column way, you can quickly see, top with top, bottom with bottom. We get a top, we get a bottom. This is my x, this is my y. That's the coordinate I need to find or need to write up. Is there any questions so far? Any questions so far?
Drop the bomb.
What?
No, sir.
Okay. I hope that is clear. Let us proceed. So that is done for translation. Now we go to reflection. Okay. So when a shape is reflected, okay, the reflection takes place in a line on a line of reflection, okay, or the mirror line. That is very important. So this line over here, we call our line of reflection or our mirror line. Okay. Now I will stop here because, and I will write down just something like this. Okay. And I will draw a shape. Okay. Let me take away the other one. Now I'm stopping here because there is something very important I want to discuss with you guys. Is when we are referring to the line of reflection and the mirror line here, it is not by default the y-axis and the x-axis. Okay. Many students, because the textbook sometimes just uses the y-axis or the x-axis to reflect the shape. And then some of us, when we write in our exam papers, you just use this. We can have many different lines. That's why this shape here is not a straight line that you can see. The line of reflection is basically a f of x. This could have been f of x, right? I'm just trying to put it in there. This could have been f of x. So we ask you to reflect the given shape on line f of x. Most of you get it wrong because you are going rather with, oh, it's supposed to be on the y-axis and not on f of x or g of x or h of x. And that becomes a big problem later on and you lose marks, even though you know how to do reflections, because you are doing it wrong here. you lose a lot of marks. So the line of reflection will either be given to you, or we will give you two of the shapes and ask you to find the line of reflection. So the line of reflection basically is a line. That's why I'm calling this line f of x, because it's how we now represent our lines when we did graphs and functions and so forth. All right. So take note of that as well. All right. So to draw the reflection, first draw the mirror line. Okay. Now draw a perpendicular line from one corner of the original shape to the mirror line and extend it for the same distance on the other side of the line. So I believe this is a straightforward process, and we do that for all of the things basically. So this is basically we draw in the mirror line, start with that line, then this shape, we get the distance or how many blocks or what is the distance from this line to that line over there. And then we do the same distance going down, and that will be our point, the same point. And we do that for all of the points of the shape. Okay, that is the last question. Repeat that for all of the corners until you can draw the shape fully, right? So this is just an example of what we are saying. And unfortunately, our line of reflection here is the x-axis, right? That is the unfortunate part. That's why I explained that first part where I said that it will not always be the x-axis. It sometimes will be f of x or g of x or another line, right? So now try reflecting shape S in the line y equals to 0. So you see now again, remember I talked about the line y equals to 0. That is just your x-axis line, all right? You have to now take note of this. And I also want to have an example here. Since we are now referring to it as a line y equals to 0, we can also refer to it as a line, right? And then we say y equals to 3x plus 4. That means it's now f of x or g of x. Then you have to first find out where is that line. Either you have to draw it in, if it's not on the graph paper, you have to draw it in yourself. And this is where that skill where I said you have to find 2 points fast, make y 0, get the x value, make x 0, get the y value. All right. So already here, if I had to now draw with the line y equals to 3x plus 4, I would now immediately, I'm now showing you this now as if I would have now answered the question paper myself. Immediately I will see, okay, line y equals to 3x plus 4. I don't see a line y equals to 3x plus 4 on the paper. I quickly do it. I say when my x is 0, what is my y? My y is 4. I have my first coordinate, 4, 0. That's my first point. Then I say when y is 0, okay? If I make the y is 0, what is x? X will be, just give me a quick moment.
Yung mafikifatabatitele manga. Yung mafikifatabatitele manga.
All right, sorry about that. So this is my first coordinate. Remember, I made the x a 0 and I solved the equation to give me my y. And then I will make y a 0. That is now for the next one. Let me just use a different color. So the next one is when my y is 0, what will be my x? So I will have a next coordinate with a 0 for y. I just need to find x. So if y is 0, this goes over, it becomes minus 4. Divide by this, then it becomes 3 over 4. No, sorry, not 3 over 4. It becomes minus 4 over 3. Okay, those are the two coordinates that I have. If you have a calculator, you can quickly solve it out. What is minus 4 divided by 3, and then you can also get your answer. And then you will plot those 2 points on the graph. Once you plot them, then you have your line. Then you start the reflection on that line. Okay. In our case, let me come back and then just show you using GeoGebra what we mean by this. It says we have 10 minutes left, so I think it's fine. I'm just going to quickly recreate this, and then we will stop the lesson
Sir,
at this one today. Yes.
Commando.
so we draw on that y equals to 3x plus 4 line.
Yes. I will show you now quickly here what it is where we mean. Okay. So first, let me just try to mimic duplicate the S over here. So this coordinate is 1 and, sorry, I need the y-axis, 1 and 4. So let me just quickly draw that over there. We have 1 and 4. That is the point over there. Then we have another point, which is 2 and 3. 2 and 3 is over there. We have another point, which is 5 and 4. So 5 and 4 is over there. All right. So I'm actually using a scale. All right. I'm doing this to scale. Ne? So please note it's slightly different from what we have in the paper over here. So now we have already, okay, F, G, and H is already taken. So I have to give my thing another name. So I'll say J of X is therefore equals to, and this will be 3X, right? And then we said 3X plus 4, right? So there is my line in. I'm just going to remove the drawing so that you can see, right? So this is the line that we have now said, the 3X plus 4 things and what you have. So instead of reflecting it on this x-axis line, we have to reflect it on this line. And now this is where the biggest challenge for most of the students will be. Like most of you, instead of reflecting it on our green line, you will start reflecting it on the y-axis, and then you will go here with this. But that is not how it's supposed to be. All right. The shape will either go into that direction over there. All right. Now, this is one of the rules that we will also have to look into later on. That is just what I wanted to explain. All right. So I don't want to do that now. We will start with the easiest one, and then later on we will come back to this demonstration that we have here. For those who are at home or somewhere, let me just screenshot it and post it in the chat so that you can at least try and attempt it. That would be a nice activity actually, to try and attempt, see who can answer this question. All right. So basically we want a reflection. All right. I just snipped it here quickly, and then we will post it in the chat if it would take it. Okay, so save. So basically this will be how we will also redefine questions or make exam questions type. We just come up with any example that we have, and then it will be there. So I've posted that picture in the chat. I will also send it over the WhatsApp group so that you can try and attempt it if you have a chance. All right. So over here, it's quite straightforward, the process that we are following. Okay. This one, again, we try and look at the points. So where the line y equals to 0 hints, the points are 0, 0.
Sir,
And
there's a question in the chat box.
somebody is asking, isn't the reflection line the x-axis or the y-axis? That is now what I was explaining now. It is not always the case that the reflection line is y and the reflection line is x. In our textbooks examples and other examples, they only show these two lines. In the example that you will probably get in the exam will be the one that I just showed you here, where the line of reflection is this j of x now, because our f of x and g of x are already taken, but we call it now, this is the line, the green line is the line of reflection that you have to use. You don't use the y, you don't use the x. But in our example here, we are using the x, okay? So the reason why I'm not explaining this one now is because it has to do with that same thing about the vectors that we did before, where you can use your vector to determine now, okay, this is my line of reflection. I will use vectors to help me reflect. Okay, there's a rule about the vectors that we will explain later on when we do vectors. All right. So somebody will ask me, what is the use of vectors? And then we will come in and explain it there later on. So here we are also trying to, yes?
Please share the exam timetable.
It hasn't been shared yet. I will ask Mr. Ashiti. Okay, so we know the line y equals to 0 is the x-axis. Okay, the points are 0 and 1, 0. All right, 2, 0, and so forth. We have explained this later on many previous lesson. Why is it called y equals to 0? Because all the y values are 0. All right.
Sir.
Yes, Ilaria.
So sir, you must send this. You know, you are recording, so you can send on the group name.
Yes.
Good.
Okay. So this we have already explained to you. It's just popping up again. You must know why it's called y equals to 0, because all the y values are 0. All right. Now we draw in our perpendicular lines. So since that is now our line that we have to reflect, then we draw in perpendicular lines. We can also draw perpendicular lines with the diagonal one, because we have done perpendicular line already. All right. It gives you a hint like, okay, perpendicular line, the gradient must be m1 times m2 must be -1. So I already know something about how to get perpendicular lines on this. All right. So you will see now where those previous lessons are coming into play. Exactly the same thing. So we don't forget what we have learned before. Everything we are using over and over again. So perpendicular lines are the blue lines that we are just drawing in. And then for this case, it's the simple one where we count the blocks as we are drawing in the line. So we'll go 1, 2, 3, 4, 5. I made the line. So I have to extend it 5 times. 1, 2, 3, 4, 5. That's where I stop. Next point, 1, 2, 3. I made the line. I have to go 3, continue. 1, 2, 3. That's it. Next line. 1, 2, 3, 4. I made the line. I have to continue. 1, 2, 3, 4. That's how we get to that different points. And finally, we just join the points. The shape will be the reflection of that shape. That is what we have there. Okay. So in these cases over here, yeah, mind the blue lines, because the blue lines are now just coming in first. But you will see now here we have one of the lines that are not reflected on. This is now, none of the lines is the y-axis and the x-axis of line of reflections. All right. So that is basically what we have to look at. Can I just end the session here, because it's 1 minute, and then I will just explain this quickly, and then we will call it a day.
Yes, sir.
All right, because this is now where I was trying to get to you guys from. So we have 1 minute left. This will